Also
Very complicated code. Hello, here are the guys from Germany. I'm Thomas and my guest today is Achim. Hello, Achim.
Hello, Thomas. Hello, world.
So today we are a little bit late because of the puzzle for today. Achim, please explain us what was difficult for this riddle.
Okay, I go into it. So for today, we are given a puzzle input like this. So we are at the hot springs, and the real puzzle input is something like this. The hashes represent defective hot springs. The dots represent operational hot springs, and the question marks represent hot spring tubs that are unknown. However, we have a second part in the in the puzzle input with list sizes of how many hot springs in a row are defective. So regarding this line, we have one defective, another one defective, and three defective. And the only way that would match is that this one is defective, the next one is operating, and this one is also defective, while these three are defective as well, but we already knew that.
Yeah. Achim, on my mobile phone, I got a game. It's called Pixel Logic. This is very, very similar to that, to figure all this stuff out.
I don't know that one, but this year I played a game called Murder by Numbers, which also was a little bit similar. However, it had the rows two-dimensional intertwined.
Okay. Also, so you have to figure out on which place could be a hash. This is part one of the first part of the riddle, but this is not all.
Exactly, but figuring this out, how to do that, was a bit difficult. And for the code, I show the method I came up first with, a brute force approach. It's a little bit interesting because it's very compact, but for the real puzzle data, it took about 3 minutes to run for part one. I didn't try it for part two. It wouldn't have had any chance.
Okay, so you need a new PC for more.
The idea
power.
for this approach is I create a regular expression. For that, I can have an unlimited number of operating hot springs before and after, in the front and in the back, and in the middle I have for every group of damaged hot springs an expression that says, okay, I have these hashes in a number of j, the number of defective hot springs in that group, and these groups are separated by at least one operating hot spring. And then I take the given string with the operating, defective, and unknown and hot springs in unknown status, and replace the question marks with either a hash or, in this case, I didn't change that back. So an hash or a point for an defective or an operating hot spring. And check all iterations through. That takes a lot of time, and maybe the pattern matching doesn't do anything to make it any better, but it's very compact.
Can you show us what is inside groups damaged? To stream this, what is the content of the groups damaged?
That is just a list of integer. I have a part of the parser here in the constructor. So for every line, I create an instance of hot spring row. And the front part is a string called map, which just is this string of question marks, hashes, and dots. And the second part is a list of integers. And I just split it, parse it into integers, and treat it as a list.
Okay, so you got the right side as a list in groups damaged.
Exactly.
Okay, nice.
So for the second part
Of the first riddle. Nee,
of the same riddle.
Okay.
Of
the
this
twist.
day's riddle.
Okay, now you come to the twist. Part 2.
Exactly.
Okay.
Now I come to the twist. The twist is that the puzzle input that we got handed out is folded. And in order to unfold it, we have to replicate both parts of every line. And we have to add 4 copies. So for the left part, we take this and copy it 4 times over and insert a question mark on after each element. So as a joining element, I have code for that. Wait, here is it. So we take the original string here and add a question mark, repeat it 4 times, and add the string another time. So
Why
that we have
4 times?
4 times with the additional question mark, and a 5th time without one. So we have 5 copies, and link them with additional question marks.
Okay.
And for the groups of damaged elements, we just copy the list 4 times over, so that we have 5 copies in total.
Difficult, yeah.
And as you can see, for the original puzzle input, then the total number of arrangements that you can have is 21. The number of arrangements is what the puzzle expects as answer. So for the test data, it was 21. And in the second part, this rises to 525,152. So the numbers get a lot larger. And as well for the real data, they get absolutely huge. So important thing, and so I had to rewrite my code because it wouldn't have stand any chance. And my idea was going from left through right, finding space for the individual sequences of damaged hot springs and so on. But my implementation was somewhat non-working. I didn't find out why. And Frank gave me the hint that it would be easier to go character by character. And then I implemented that. And when running, you come into we go into this method. And starting with these parameters all initialized at 0. So we start at 0 index for our map data, at 0 index for our groups, and at 0 index for this processed field. I have to explain that we're processing character by character. So if we have a sequence of damaged hot springs that have to be consecutive, we have to count how many of these damaged hot springs we have already processed.
Yeah.
So when we go into this, we enter here, look up the current character from our map data. And if it is a damaged hot spring or an unknown, we can process that as a damaged hot spring this way. Or if we are already about to complete a group of damaged hot springs, we go this way and would switch over to the next group and set the processed counter back to 0. Otherwise, if we are still ongoing, we remain on the same group, but increment the processed counter. The other possibility is that we do not decide to process the question mark as a hot spring, but as a intact hot spring, or it is in fact an intact hot spring. In that case, we just increment the map index and keep group index and processed as they are. But in that case, it is important that processed is still at 0. That we didn't start processing the sequence of hot springs, because otherwise we would tear it in 2 parts, and that is not allowed.
Okay.
Also
Very complicated code.
Also important when we are finishing a hot spring. I forgot that. Sorry.
Yeah.
You might notice this +2. The thing is, when we are completing a hot spring, we have to check whether the next character is a known defective hot spring. If it isn't, we are running with a solution that is no solution. That is important. The other thing is, if we're really completing this group, then the next field cannot be a defective hot spring. It is either a known working hot spring or an unknown, which must then be a working one. So in that case, we jump ahead 2 fields to skip that one and continue one further with the next group.
Wow. How long does this code run on your machine?
It runs fast. I will
Okay.
start it, and it's done.
Okay.
So something like a second.
Okay. Wow.
One thing that helps with speed is caching. Point is, you can cache partial results. Because if you are at a certain map index with a certain group index with a certain processed counter, the result is always the same. It doesn't change, so you can cache it. And that helps because processing that string, especially if it gets longer, can lead to a multitude of branches that you have to process over and over again. But if you cache the results, you don't need to reprocess them, and that helps a lot with speed.
I got it. Achim, what was the hardest thing in this puzzle, the hardest challenge for you?
This code doesn't look that much complex, but actually piecing that together, ooh, that was something.
So we all hope that tomorrow the riddle
the
is more
variant
easy.
of this that I had in the working myself that didn't really work was approximately twice as long. And yeah, it didn't
Now you
work.
got 120 lines of code, more or less.
The total class has, 125.
Yeah, nice. Good. Some last words for today?
I'm waiting for next day's riddle. I hope I will be better at that time.
Yeah. I wish you luck. Then, big thank you, Achim, and we see us tomorrow. Bye bye, everybody.
Bye.